Hi everyone, I'm David Pike, otherwise known as Connector Geek. Welcome to our latest Ask the Expert interview, where we are going to talk about some exciting new things that are going on in the world of automotive. There are some big trends going on in the world of automotive, and there are several revolutions all happening at the same time. Electrification, in-vehicle connectivity and experience, connectivity from the vehicle outside, and the big drive towards autonomous driving. So, to talk about these things, we are going to need to look at the amount of electronics that are held within the car. And that is leading to a big change in the way cars are designed. And the end result is something that's going to be known as zonal architecture. And to talk about zonal architecture, I am joined today by a special guest from Molex, Ryan Price, who is the Director of Marketing for the transportation industry. Welcome, Ryan. Good to have you with us.
Thanks, David. Great to be here, coming to you from the Detroit, Michigan area, automotive capital of the world. So again, exciting to be here and talk about this very innovative and transformational topic.
It's an exciting topic, and obviously Detroit is going to be one of the key centres in the world about this. Bear in mind the amount of industry there that's capitalising on this new technology. So in the introduction, I talked about zonal architecture, but I think it's probably important to look back a little bit and understand how we've got to where we are now. So from a start, how do automotive electronics look now, and how have they evolved that way?
With the movement towards the connected vehicle, the cars are exploding with electronics, more and more cables, more and more wires. The architectures are very complex today. So, if we first want to take a step back and sort of understand what's driving all of this, I think that would be a really interesting topic for our viewers to sort of tie back and ground themselves on the four ways that at least Molex is looking at this. And, they're very similar to the case, to the four that the industry is looking at, but shared mobility is not really something connector folks are that wrapped around. So we've substituted that with in-vehicle experience. So maybe if we throw up slide 2, we can kind of step back and go through those. That might help ground us.
Lovely.
Great. So I think, David, to your question, there's a lot of market drivers happening that are really transforming the way that automotive manufacturers, both the OEMs and the tiers, are thinking through the next generation of vehicle. And so we've sort of bucketed this into 4 drivers. There's connectivity, there's electrification, there's this whole move towards autonomous, which, ADAS is a driver there, and then the whole in-vehicle or cockpit experience for the user. And then there's all these design enablers. These are the key terms that our customers are talking about and trying to solve these complex problems in the vehicle, whether it's zonal, whether it's the noise and vibration, whether it's Ethernet or V2X or modularity or miniaturization. These are all these key phrases and, again, design challenges that the automotive industry is trying to tackle because the vehicles are becoming so much more complex in the architecture.
And so, if we're looking at this kind of complexity, how do new features get incorporated into vehicles? How do manufacturers add these new features that everybody seems to want?
And therein lies the problem, right? So today's architectures are very flat. In fact, they call it a flat architecture, where they're trying to plug in different modules and different peripheral devices as they expand their ADAS capabilities. But it's sort of this hodgepodge of CAN and LIN, and now the introduction of Ethernet, all sort of plugged in, adding lots of cables. If you look at a typical high-end vehicle today, there's upwards of 2.5 miles of cable in a vehicle. It's about 150 pounds. I think it's the second heaviest piece of equipment in a vehicle besides the engine. There's sometimes up to 700 connectors on a very connected vehicle, with 3,000 individual wires, 40 different harnesses that make that up. And when you talk about the EV space, you're typically adding about 30 more pounds of harness just for that electrical infrastructure that connects the battery. And all of those have to connect about 150 electronic control units throughout the vehicle. So all these electronic control units being sort of talking only to themselves, not really networked together. And so it's a major cluster for manufacturers to try and integrate all of this into their vehicles.
So this is making vehicles incredibly complex, and it's not really something we were going to talk about today, but it's worth mentioning. All these hundreds of pounds, hundreds of kilos of weight in terms of the cabling. It's important to remember this is one of the few components in the vehicle that's still handmade, isn't it?
That's right, handmade. And when you see videos of a typical automotive manufacturing plant, it's really robotic, right? A lot of hands off. But as you mentioned, these harness facilities have tons of labor. It's all done by hand. There's a lot of room for error. There's a lot of room for misalignment and quality concerns. So this flat architecture is causing a lot of challenges with connected vehicles.
And so we've talked about the complexity of the wiring, the cost. I'm assuming the cost of this is going to be enormous. You've got all this manual labour, and you've touched upon the potential points for failure compared to robots that can do spot welds from now until next Sunday quite happily, and every single spot weld is going to be identical. If you've got such a major component in the hands of people, doesn't matter how well trained they are, there's always going to be that potential for an error. And we've talked in the past, I think, about the number of failures that are caused by the electronics. It's the highest failure rate, isn't it? The highest reason for dissatisfaction with cars.
It is, and the warranty claims are huge, and that's one of the reasons for this new Arena 2036 movement, which is to really try and use more robotics in the manufacturing process, especially around harnesses. And so, we're doing a lot at Molex to develop new next generation connector technologies, especially as we move into the domain and zonal architectures, which we'll talk about in a minute. And these connector systems are more hybrid, and they're meant to be used with robotics, which is sort of where the future's headed.
Fantastic. So just to focus on this slide just for one more second, just everybody keep in mind that number. So each one of those ECUs is a small device. It could be a big device, but it's a piece of electronics that must be connected and is currently connected by this enormous great harness.
Right, and if you think about what are those, right? So every time you hit your trunk button and your trunk pops open, that's an electronic control unit, right? I mean, when you roll your windows up and down with the electronics, those are two little boxes. So all of these creature comforts that we have now are all controlled by a small little ECU, a little mini computer that needs to have a wire hooked to it and needs to be somehow networked together, and that's where the complexity lies.
Okay, so we've looked at how cars have evolved and they've kind of accumulated, haven't they? As designers add new devices, add new features, they just throw new equipment onto the vehicle, and
Right.
we've got this situation which is no longer sustainable. We've got a very heavy harness, we've got lots of components, and so the designers are looking for a completely new way to solve this problem. And so if we look at the next slide, I think it'll give us a very clear idea of what we've got at the moment and where we're going. So at the left-hand side of that slide, we've got the distributed architecture, and that just gives you a bird's eye view of the kind of struggles that the designers are up against. They're trying to fit more devices in. Then the image below it on the left-hand side gives us a different way of looking at it, and that's zonal. So Ryan, could you just, from a top level at the moment, talk to us about what zonal actually does and what it means?
Yeah, and this is where it's really exciting in the automotive world to see this. And we do have a couple manufacturers already moving into the zonal space. Most of them are still in development, talking about the architectures, but it's really critical to notice in the distributed, all these little, colors are all those different ECUs we talked about, and they're all just kind of a hodgepodge, distributed throughout the vehicle, not really communicating with each other. So when we go down and look at zonal, they're placing the ECUs in the zone, whether it's the front left zone or the right rear zone. And then all of the peripheral devices in that zone will communicate to that ECU and that ECU to a centralized computer, which networked together. So really, it's fascinating to think that all of these 2.5 miles of harnesses will be shrunk down because you only need to go from your zone to your box, and then from that box to the central computer using a high-speed cable, right? Because all that bandwidth going from zone to zone or to the central computer will be, into this 10 gig range using high-speed cabling. But all of those zones are going to drastically reduce the weight and the complexity of those harnesses.
And so, Ryan, expanding on what you said, this is a much closer view of that zonal architecture, that idea of each of those individual modules talking to the zonal module or zonal gateway, which then deals with the central computing cluster and networks everything together.
That's right. So if you think of a typical flat or distributed architecture today, and let's just take an infotainment system as an example, you would have a cable that had to run from the very front camera in your bumper to the very rear bumper camera, and then connect back into the infotainment system so you can get your surround view system, your surround view camera. If you take into consideration zonal, it changes the whole game, because the front camera would be connected to the front zone, the rear camera, the rear zone, and then it would be piped through one cable, a high-speed cable, into that central computer, networking all those zones together. And so again, you drastically reduce the complexity, the weight, the quality, and you can easily plug and play, because this is more of a software-defined system versus before it was a hardware-defined system. So again, that plug and play capability, and especially with the advancements of Ethernet in the vehicle, is going to drastically make the vehicle architecture much more simple, so we can add the peripheral devices as we move up the levels of autonomy.
And I think it's worth talking about for a second. Each one of these zones is not just going to be handling one particular task. Because if we look at cars at the moment, you'll have that infotainment network throughout the car. And then you'll have a safety network that will deal with things like the ABS systems. Then you'll have
Right.
a power network, and they'll all be kind of layered on top of each other, not really talking. So I just want to make it clear, each one of these zones is going to be controlling all of the functions in that area.
All the functions.
So
That's right. No, David, that's right. And maybe if we can go back to slide 4, we can sort of show an illustration of what's happening there, which is actually bringing us into another trend, which is huge right now. So David, that picture there in the middle of those 6 different ECUs was exactly your point. In the current architectures, you have all these ECUs moving into this zonal. You're going to create a much larger box, but you're going to put all of those functions into that box. And so that's an illustration below, which is an actual representation from one of our customers of an infotainment node in the front that controls your TCU, and it's that zone in the front of the vehicle. And just look at all of the amount of electronics packed in to that one box. Instead of 6 boxes, it's one. And that's leading us into this whole next generation of trend, which is miniaturization. Everything is shrinking. Inside the box is shrinking. They're putting boards on boards. Outside the box, we're shrinking all of those IOs. And so that's what's leading to this consolidation and this miniaturization trend.
So we're talking about this central computer that's packing all this technology into one place rather than duplicating it all over. And you've mentioned high speed, so I'm guessing that's one of the big changes we're going to be looking at. What are the speeds we're seeing in terms of data communications in cars at the moment, and what's that going to go up to?
Yeah, no, that's where there's a lot of transformation as well. There's still a lot of these 10 megabit speeds to controlling a lot of just the standard equipment in the vehicle. But we are seeing customers reaching that 1 gig speed, and there are a few that are actually targeting 10 gig in the next year or two with their sights on 25 gig. And if you think about the datacom world, they're at 256 and above. So, we're really catching up. And I think that's why we coined the phrase data center on wheels. With all of these sort of data functions now coming inside the vehicle, the speeds and feeds need to increase. Some of these cameras and some of the other safety critical features in the vehicle need to have very high speed and redundant networks. And so we're leveraging a lot of those capabilities, again, from our datacom experiences into the vehicle. And we're super excited to see speeds up to 10 gig coming, because that's where we can really employ a lot of new capabilities and new techniques into connector design and development to create these connectors that have both low speed and high speed, which we're calling these sort of data signal hybrids.
And we've also got that central computing cluster that's going to require an awful lot more computing power.
That's right.
and therefore is going to need more power. We haven't really addressed the question of power at the moment, about how the electronics in cars are currently provided with power. What are the changes that are going to happen with Zonal when it comes to powering this electronics?
Yeah, there's a lot of discussion in vehicles that potentially going from 12 volt to 48 volt. So there's lots of implications that happen in the vehicle architecture when you discuss more power. By and large, we need to bring more power into every connector. And so again, these hybrids that have slow speed signal, high power, and high speed all mixed in one pose design challenges because there's mixed layouts, there's EMI and EMC issues in the vehicle, there's thermal management challenges. And so trying to pack all those into that box is really where the future is. And that's where Molex is spending a lot of our time with every customer in the market, really trying to design for their perfect piece of equipment and their perfect thermal and EMC management.
And so when we start talking about the benefits that Zonal is going to bring to not just the car designers, I think we've covered that to a certain extent, because we've talked about the fact that we're going to be reducing the number of cables that we're talking about, the amount of cables that we're reducing. If we move from 12 volts to 48 volts, we can actually make the gauge of the wire smaller. And so again, the mass of the wire goes down. So from a designer's point of view, Zonal's going to be bringing quite a lot of advantages just from the act of building the cars. But I'm guessing that Zonal is going to bring all sorts of other advantages, especially when we're talking about things like ADAS and then the move to autonomous driving. The amount of data that's got to be collected and processed in the vehicle, Zonal is going to play a big part in that, isn't it?
It is, and it's really critical for us to remember that they're all tied together. The ecosystem is all tied together. So when we talk about electrification, and then we talk about all the different ADAS peripherals coming, and then we talk about zonal, we talk about miniaturization, they all sort of work together in this ecosystem. So to answer your question, zonal, right? So the more peripheral devices being jammed in a vehicle, zonal is just so advantageous for this plug and play, putting things in each of their zones. I was at a tier 1 2 weeks ago and saw a brand new US vehicle that they were doing some testing on with 7 monitors in the vehicle. So 7 high-speed LCDs, right? Each of them connecting to a zone using a high-speed cable. So imagine that in a domain or in a flat architecture, the amount of cabling needed, the amount of weight needed. So as we see, sometimes there's up to 12 and 14 cameras in a vehicle as well, right? So we're packing all these electronics in. Zonal is just making this much simpler from both a software, a plug and play, and also just a cable routing, cable management standpoint.
So, and we talked about quality earlier. We talked about the failure rates associated with harnesses. Even if we don't make the move to robot assembled harnesses, because we've got fewer connectors and therefore fewer connection points, I'm guessing that's going to have an improvement on reliability as well.
No, it will. And think about a harness that spans the full length of the vehicle. It could be 8 meters, right, from the front to the rear bumper. There's many inlines, and oftentimes multiple harness manufacturers are producing parts of that harness, shipping them to the facility, and then they're stitching them all together. So therein lies, quality concerns, workmanship issues. And so when you, again, go into this zonal architecture where it's one cable plugging from a peripheral device into a zone, it's a short cable, it's one, there's no inlines, right? The complexity is solved. So that's why this is really taking off as a transformational trend in the industry.
And so I want to talk about connectors. Because that's what I do. I enjoy the connector side of this. And automotive connectors for many years have been, should we call them a little agricultural? Some of them have been big and clunky. They've been, we haven't exactly advanced much in terms of automotive connectors for many years. However much the vehicles have advanced, automotive connectors look kind of familiar. But you've been talking about this new generation of connectors that will need to combine, that provide a hybrid of data and signal, low speed signal, high speed signal, and potentially power. So let's touch upon the connectors, because it's not just one connector, is it? We've got an inside the box aspect, then we've got an outside the box aspect going from the central compute cluster to the zonal, and then beyond to the devices. Can you give us an idea of what the connectors might look like in the future?
Yeah, no, for sure. And I think it's really interesting to note that both the mobile industry and the datacom industry are playing a huge role in influencing the way that these ECUs are now being designed, right? So think about mobile for a second, right? Your mobile phone, your iPhone, your Android phone, very small connectors inside, board stacking. So when that is being employed into the automotive market in these ECUs, you're seeing micro miniature board to board and wire to board connectors inside the box to help move those signals around or up and down through the boards. And so again, mobile devices having a huge impact in our industry, especially with V2X and some of the antenna technology that's being carried over from the moldable devices as well. And then we look outside the box and look at some of those high-speed signaling, again, coming in from the datacom world, leveraging a lot of those same capabilities and connector designs that we're seeing from the datacom side, whether it's the high-speed coax or whether it's the high-speed differential pair. And then taking all of those, and again, something new in the automotive industry, but jamming those all into one housing and working that into a hybrid connector system. So you're removing sometimes 6, 8 connectors on a board. You're placing one hybrid connector. You're saving a vast amount of board space, and you're also saving all those different plugins from a harness standpoint into one harness. So again, space savings, labor savings, EMI, EMC, thermal management, all coupled into one new solution. That's, Molex is really, leading the industry. We have multiple new designs coming out for different customers to solve some of those interface challenges that they're facing today as they pack more electronics into these boxes.
And another subject that's quite close to my heart is always talking about the environment, because some of these connectors will be safely protected inside a box, some of them will be inside the cabin of the vehicle. But when you start putting connectors in the engine compartment, for example, or on the extreme edges of the vehicle, if we're talking about sensors and braking systems, these things are going to be exposed to road conditions, the elements, the rain, the wind, the weather. So I'm guessing you've got that challenge as well. You've got a high-performance connector that also needs to be protected from these tough conditions.
That's right. The whole ruggedized, system with, advanced capabilities in the way we're doing matte seals today to really provide that, quality for, you think about an electric vehicle, which could be a 1,000,000-mile vehicle. And so everything else, all the components have to be able to withstand and last that long as well. And so we're really developing our terminal and connector systems with that in mind, that we have to, make these things last a lot longer when electric vehicles come out, because there's going to be a lot less maintenance in the vehicle. The vehicle will last a lot longer.
And I'm going to put you on the spot on this question because there are elements of different industries that seem to thrive on standardization, especially when it comes to connectors. If we look at networking connectors around the world, there are only really a few connectors that get used inside offices. Whereas in the automotive world in the past, there's been a profusion of different types. Is there a consensus in the industry that will go down to a particular standard, or is the variety going to stay with us forever?
Yeah, that's the $64,000 question. I think we're still seeing a lot of manufacturers, both on the OEM and the tier side, choosing what they want to choose. And there is yet to be some consolidation down to a few. We do see some bright spots, though. I think when you look at mini coax, we are seeing the largest trend driving towards the Molex and Rosenberger solution of HFM. And I think that's, by and large, the new standard, the sort of de facto standard for some of the mini coax that are powering, the antennas, some of the infotainment system, the cameras all throughout the vehicle. But when it comes to high speed, there's still a horse race between a few different systems out there. And then when it comes to everything else, boy, take your pick. There's connectors everywhere, and there's no standardization yet.
That's fair enough. I think the mention of RF is worth talking about as well, because up until now we've been talking about board-to-board connectors, and if we talk about the cell phone connectors, people see them as sort of linear, straight board mount connectors. But there are still quite a significant number of RF connectors in this world, especially bear in mind, almost every wireless connectivity system, and in fact every wireless connectivity system, will use some kind of radio system, radio frequency. And so RF connectors are as vital as they ever were.
They are. In fact, we're seeing a huge growth rate in the use of coax in vehicles. Coax is typically lighter and it's typically a little bit less expensive. So again, camera systems seem to have moved towards the coaxial space. All of the antennas are coax, and some of the other peripheral devices are moving that way. But again, it depends on the OEM chipset needs, right? And the chipset manufacturer, and whether it's differential pair or whether it's coax, they both have their advantages and disadvantages. But we are seeing a huge growth in coax in the vehicle today.
I'm really excited about this particular topic. I've talked with Ryan and other guys at Molex recently a lot about zonal, and it's very clear that this is the future of automotive design. And I think a lot of what we've talked about now has revolved around our idea of the family car, that the electric vehicle sitting on the driveway. But this does also apply to commercial vehicles and industrial vehicles as well, doesn't it?
No, it absolutely does. And when you think of the trend of electrification, it's happening everywhere. It's happening in my lawnmower. It's happening in commercial vehicles, happening in agriculture. In fact, if you look at the agricultural companies, there's a couple of them that are actually way ahead of the vehicle market with autonomous tractors for the last 5 years out there, farming the lands. So, all of these new design enablers really span across everything related to transportation. And that's why I think it's so exciting for no matter what industry you're in the transportation, they're all moving in this sort of electrification, and they're all moving in the zonal space as well.
And one other thing that we've talked about in the past, when I've spoken to you before, you've talked about the different models of vehicle use of transportation. People my generation assume that you go out and you buy a car and it sits on your drive for however many hours inactive. But that's not the trend that we're seeing. Younger generations and certainly urban dwellers, they're not looking to buy cars, they're looking to buy time in transportation. And I'm guessing Zonal helps out with that kind of model as well.
Well, it does, and that's sort of where the shared mobility model comes in, right? And so if you look at, especially some of these large urban areas, in fact, I have many friends that don't own cars. They live in Chicago, and they just use the shared mobility model. And you think about both electrification and zonal stretching out that car's life cycle, right, to more of that million-mile car. It's a shared mobility car. So instead of sitting in your garage for 23 hours a day, that car's being used for 23 hours a day, moving different people around. And so I think that model is really here to stay, especially in some of these big urban areas, especially with the younger generation. And so, designing the connectors and the robustness of the system to be able to last in these new vehicle architectures is really key.
I think that's been a fantastic introduction to zonal architecture. I've told my kids before that the chances are when they're old enough to be driving, they'll be driving electric vehicles. And I think that's probably very true. But bear in mind what we've seen. It's not just that they're going to be electric, it's that they're going to be a completely different animal to the sort of thing that we see sitting on driveways at the moment. Not just power, but how this vehicle interacts with its world around it, with us as drivers or passengers. And Zonal's going to play a big role in that future. So, Ryan, I just wanted to sum up and say, what does Zonal mean in terms of the time scale? When are we looking to see vehicles on our driveways or on our roads that will have this technology built in?
Yeah, no, that's the great question. So most of the OEMs around the world are already integrating zonal pieces into their architecture today. I'm thinking model year probably 2024, 2025 is when we start to see a lot more. We are seeing a couple out already. In fact, Tesla sort of moved in that direction already. We're seeing a couple other new entrants who typically have a little bit faster design cycle speed and typically will try things that are a bit newer, already coming out with zonal. And then we're seeing some of the Far East manufacturers really leapfrogging and going to be releasing zonal architectures here in the next couple of years. So, exciting for me and exciting for Molex and exciting for the connector world to see that we're moving from that flat to that domain into that zonal world here in just the next few years.
That's been brilliant. Ryan, thank you so much for leading us through this world. This is a world that I think most of us will actually see and benefit from in the near future. Whether or not we are mechanics, whether or not we actually see under the covers of our vehicles and see how they work, simply how we are going to use the vehicles and how we benefit from them will change for the positive when it comes to zonal architecture. Ryan, once again, thank you so much for walking us through this new technology. Thank you for giving us an insight into how Molex sees the connectivity of these devices and talking to us about some of these technologies.
Yeah, absolutely, Dave. It's my pleasure. And again, we're in a very exciting time in the automotive industry, and we look forward to a bright future with many more connectors and interconnects and high-speed cables to help solve those needs.